Okay, so we have lots of stuff going. First of all, we want to introduce that we made spells are event-driven services that allow specific Aqua scripts to be triggered by an event, like an incoming webhook call, or connection pull event, or timer-based event, or probably an on-chain event. And we think we're going to introduce a huge improvement over the scheduled scripts functionality we've been using prior to that. So tonight we have Alexei on our call, who is actively developing this feature with his team. So if you have any questions on that, please ask them on the AMA session later. We also made some compiler and DX updates. So we are continuing to improve Fluence CLI, and we started to move the functionality from Aqua CLI to Fluence CLI. So if you update to the most recent version of Fluence CLI, you'll see that it's being actively developed. There are lots of new features, so please check it out. And we've released Aqua Compiler version 0.8 with some quality of life improvements for all the Aqua developers. We also made several housekeeping updates for our Docker Hub repositories. So right now it's easier to find the right Rust peer container flavor. So if you want to deploy it on your machine and develop, and we've greatly improved our end-to-end test functionality. So we are constantly working on the quality of our codes, and yeah, this is something we've been improving. Also, we had really good progress on Marine and Aqua VM refactoring. So the machines team is working on like 3 major directions. So the first one is that the Aqua VM refactoring, and the aim is to make Aqua VM more modular, production ready, and be able to use different types for results like IPLD. We also doing some really important work on Marine refactoring. We want to be able to use different WASM backends there. So, and to have like the best of both worlds, we want to have like the modern version of WASMer and WASM time, and we want to be able to use them both. Yeah. So that's what we have for Marine refactoring. We also introduced service call signatures that will allow Aqua VM to check for particle flow and service execution results in a more secure fashion. And we introduced the ability to use CIDs in data produced by Aqua VM. The goal is to address the results by CIDs and use CIDs to handle values in a special structure produced for every executed canon instruction that we introduced in October. So that's more or less what we have for technology progress updates. Maybe you have any questions, or because, well, those are really huge. We put a lot of work in those. Okay, so if you have any questions, then just drop them into the chat, and we will address them later. So right now we can like move on to probably to the demo section. So who wants to be first?
That goes fast.
So
am I audible, Jura?
Loud and clear.
Okay. Then I'll go first. I was thinking you had some presentations first, so I was sort of lurking still. Can I share my screen?
Yeah, absolutely.
There we go. Now we'll have vertigo. Let's go. Okay, so my name is Jura, and I'm a freelance developer in Amsterdam. And this is my first project, my third project with building with Fluence. And I'm slowly getting the hang of it. And I hope that you guys and girls will see that it's improving. I also hope that my internet zooming skills are getting better, so we have a good presentation. For me, the unique quality of Fluence is that it allows me to program with other protocols in a peer-to-peer manner. So I can program, orchestrate workflows between various protocols on a peer-to-peer network. And for this project, I built a marketplace on Fluence testnet, where Fluence nodes can advertise that they are offering a specific service of access to ComposeDB. And ComposeDB is a decentralized database. ComposeDB, for whom don't know, is like the successor of to Ceramic, and Ceramic was a method to do immutable data on IPFS. And while with Ceramic you could make like single collections, with ComposeDB you can combine these collections into more complex structures and describe and query them with GraphQL. And both ComposeDB and Ceramic are especially useful for mutable social content such as profiles, blog posts, tweets, whatever. My demo is here. I hope you can see it. I'll refresh. So you'll see that in the front end in the browser, we've created a Fluence JavaScript peer here, and it's connected to the testnet over a random relay. And it has asked to the network, are there any other Fluence peers advertising that they would like to help me with access to ComposeDB? And luckily, there are two such peers, and both of them are located on my home server. And let me see where I am in my story. Oh yeah, I forgot to mention that I am supposed to paste. I'll paste the link in the Zoom call. There is the link to the front-end demo, which you can actually use. There is the link to the GitHub repository, and there is my email address. So you can use this one, and you'll need MetaMask later, and you can also use it on your mobile with the Brave wallet or an Opera wallet. Anyway, so we've asked the network if there are any providers, and two have returned a yes, and they also gave us some information about the data structures that are indexed. You have to imagine that those peers that are advertising, that are providing that service, they have their own Ceramic node and their own IPFS node, and an SQL database that stores the data content that it gets from from Ceramic. So both two peers, we have like their own Ceramic node. So when I will connect to one of them, it will immediately start returning the content from one index, and that index is a collection with profiles that combine an Ethereum address with a profile name. And you'll see them here in the corner. And I'm also getting prompted to log into MetaMask. because the front end doesn't know which Ethereum account I am yet, but will soon, I hope. So there we are. Like I said, there is a data structure that is combining like a profile name with an Ethereum account. And now the front end knows that I have connected my MetaMask, so I have the private keys for this Ethereum account. And I go edit. And when I press edit, I want to start the session. And this session is done with did session. And did session is a piece of code that is also built by Ceramic, and it's used to have like granular access to the database. Anyway, so I'm going to sign a session with my private key, which will then be ported to over Fluence to the ComposedDB database. And there it says like, okay, this guy can change this specific entry, which I'm going to do now, and I'm going to save it, and there it's gone. And now, for example, I can do a lot of things, like I can change, I can go to the other Fluence node, and I get the same content back, because in the background, behind the scenes, the two different Ceramic nodes have already synced their data, and yeah, it works. So, and I can go change my Ethereum account. I can make a new Ethereum account in MetaMask, and then it would still all work. And yeah, you see, I just changed the Ethereum account, and I can change another one. I have again need to do a signature. The signatures are stored in local storage. If there's a question, I can show that. Anyway, so the whole thing sort of works. Now the question is, how did I build it? Or how is it built? For the people that are somewhat familiar with Fluence, you know that with Rust, you can build microservices, and then you can deploy them on nodes on the network. And you can configure these nodes in a way that they can use the executables that are in a folder, in the user bin folder on the Docker container of the Fluence. Most people will have maybe used the curl adapter, which is hidden underneath here, I hope. I should have gone for the other option. Anyway, so here, this maybe look familiar, that you can bind the service to an executable in this folder, and most people use the curl. But if you're working with another protocol, it sort of defeats the purpose to go over HTTP to an RPC of the other protocol. It would be nice to actually use directly use the protocol. So here is my ComposedDB adapter. At first, I was trying to use the default CLI of ComposedDB, but that didn't work within this specific Fluence context. And then I tried a different solution, a second solution, which was very complex. When I finished it, I immediately realized that there was like a more simple solution. And the simple solution is to just build your own CLI. And so I used I basically used NPM libraries like Yarx, which is used to make a CLI, and the standard libraries built by the Ceramic ComposedDB team, and made it into my own custom CLI. And then I have to package it, and you have to package it into an executable. You can see how I did that in my package.json in the repo. Then I take the IPFS distro for the Docker container, but I just include my executable in there. And then here you can see like the whole Docker Compose file, which I use to spin up the nodes. And then you can see that if you want to use Ceramic, you need like a different container with the Ceramic node, and Ceramic also uses their own little slightly different IPFS container. So there are also inside the Docker Compose YAML, and you can find them all in the repo. And my offer to anyone who wants to try this in their own project, to make use of this sort of NoSQL database, sort of GraphQL database sort of functionality. If you want to use it in the project, I'm happy to help you. And yeah, that's it. I'm of course awaiting questions.
Wow, this is really exciting. While you're presenting, I have like registered in this tool as Fluence fan 2023. So I just like added my identity to this tool, and it's really.
Let me check. Where are we? Yeah, there we are. Hello, Jura. Also, who did hello, Jura?
Yeah, that was me. I have a question. If I edited one entry with one MetaMask address, like, can I re-edit it with another address? Like, how does access control works?
Okay. So basically, what this session does, that it takes your Ethereum account, and from Ethereum account it derives a DID, and in this case it's the same. It uses a method which basically takes your Ethereum address and uses this as a DID. And with that session, with that signed session, you can only change one entry. No. I had this one, but I had this one open. I didn't. It's here. No, it isn't. Here you can see like the GraphQL schema, which you sort of start with when you ask you send that to Ceramic, then Ceramic creates a whole bunch of stuff, and later you ask Ceramic to start indexing it. But here you can see there is like account relation single, and that means that only there's a collection of items, but only the person with the right DID can change the one item.
Okay, I see.
But you could also have a collection that is maintainable by more people.
Okay, and like when I like how actually this action to edit works. I mean, you have some Aqua that calls the peer that has Ceramic adapter and basically passes the CLI command to it.
Yep. And if you want to see it, so there will be front end, source, services. So then I have an Aqua service where all the Aqua calls are like there. So here's the query and here's the mutate. So here then it's calling this Aqua function. Which is here. Yeah, it is like an Aqua function. And then it goes to the marine surface. And I'll skip this one because I immediately go, no, main. So here's the query. Yeah, so that then just makes the call. And one of the things I'm still debating, and it's a question for you, is that in this specific case, I made the adapter as clean as possible. Like, let's see, let's go to, because the adapter is basically the piece of Rust Marine code that should be interoperable or should be exchangeable and for other people to use. And at first, now it's only basically this little thing because I wanted to keep it as clean as possible, just like the curl adapter. But lately I started thinking that because I'm actually the person who wrote the CLI and know exactly which methods are in the CLI, I should actually just write all the functions here in the adapter, because, well, that's the only way you're going to use it anyway. But that's up for debate. What actually is an adapter? Or, yeah.
Adapter is anything what you want it to be, sure.
Okay, thank you. So what do you think then, Bernard? Should I?
I think you should. I think you should. But before you do that, I think you also should tell people your very cool use of registry and how you use the value field for the CID.
Okay.
Because I think that's very educational.
Okay, so there is in the repo, I made one of those diagram sort of things that people like here. So what needs to be done is that when the service is deployed on the node, the actual service that it's going to provide needs to be initialized. So you need to send an init command to the node. And this init command includes like some information about for ComposeDB in indexes, as well as the private key of the DID, not the Ethereum account, of the DID that actually controls the index. So that's a different DID than the ones that control the individual entries, but the one that controls the index. Then it goes to the Marine service, and when the Marine service tells the custom ComposeDB CLI to start indexing, but it also creates an object with information about itself, how it can be reached, how the other parts in the Docker network can be reached, and also including again the information about the indexes. And that I store on IPFS. I call that the contractor details. I store them on IPFS, and this specific IPFS is then returned to the Aqua function. And next up in the Aqua function is the method to register to the marketplace, to the registry, in my case, a marketplace. And I use that CID in what you said, the value object. So there's like one object, one key called value, and I store the CID in there. So when the front end is like requesting the registry to give a list of providing Fluence peers, then immediately it can get through the CID can get the additional information and just maybe check out what if you actually want to use that provider, maybe, you know, that could also be included in their stuff about any payments or whatever you want to think of. Was that an answer to your question, Bernard?
Oh yeah, no, I just wanted people to hear it from you because I thought it was a really cool use of registry, and people should hear about it. They may not self-discover just by looking at the repo.
No, but I think I got the idea from another project that you brought to my attention.
Yeah, but it was a really good use. So I have one more thing, and we sort of offline, we went back and forth on that. A lot of people want to use DIDs, and then they run into a lot of problems right away because the standard isn't really that tight. You said you use Chain Agnostic Standards Alliance, CASA, as your guiding principle to make decisions on
the lightning beacon. Yes, okay, that's a working group where different teams working on DIDs just come together and talk. And they all aspire to be interoperable. But you know, still they have to make their projects that work with their own other products. So interoperability is like an ambition, right?
Yes.
Yeah. So and because this is I've tried compose DBs or from the same team, the did session, or sort of from the same kind of source as the product compose DB. I've used them together and they work very well together. But I don't know what things you run into when you start trying the same session on something else. Probably needs some work to be done then.
Thank you. I'm done torturing you. It was awesome. Great. Thanks.
Okay. Well, you're most welcome. I thank you guys for building.
Yeah, thank you very much for sharing a very cool demo with us. I think that DID is one of the really promising technologies, and it's very exciting to see that Fluence is used to sort of showcase it, to be a backend of it. And
so one last thing is that, so in this, if you extend this idea into sort of a more professional product, you could call it like a decentralized database as a service. But you could, you know, on Fluence, but you could also have like a decentralized identity as a service on Fluence that would basically like manage the differences between like these sort of different DID methods and sessions. Perhaps. Anyway, I'll shut up. Bye.
there is
I have one question. I have one question. How does the sync works? Is it through Fluence and Aqua, or is ComposeDB connected? Are they connected and replicate themselves?
The ceramic nodes are connected to each other.
Okay, thanks. And there is a question in chat.
Yeah, there is a question in chat. Can you please share a bit of how we could set up the project on Windows or on Linux machine? Because, well, it's very
Please send me an email.
So maybe you can point us to some GitHub repo where
Yeah. So the GitHub repo is in I included the GitHub repo, I think, right?
Oh, yeah. There is.
Am I actually still sharing the screen? Yeah, so the GitHub repo is in the. But let's if you got questions about it, I really like to help. So then just send me an email or something.
Well,
you could also just ask me in the Fluence Telegram chat or something.
Yeah, ask in the Fluence Telegram chat so it's available to everybody, and Jura only has to do it once.
Okay.
Okay, well, that was amazing demo. and amazing questions. So right now we will be moving towards the ETH Denver plans, and I'm very excited about them. So guys, do you see my screen?
Yep.
Okay. So I think Anna and Nadia will help me with those. So Anna, could you please tell us what things are ahead of us in Denver?
Sure. Yeah, so we have a pretty dense weeks in Denver. That's starting February 27th with Decentralized Network Summit. That's the event for everyone, for technical people and non-technical. We are having our partners there giving talks, presenting their tech. Of course, Fluence team will be there. And we're probably going to have panel discussion and all the networking and mingling after the event. This happens in one of the official venues of ETH Denver, Biddle Hub workshop stage. The links we will share also later in all the communities. It's open, the registration is open already. So if you're there, very welcome to join in person. If you're not, we are going to have the live stream, so you can see all the content online and in the recording. Then we have 1st of March, we are having Fluence workshop for those who are attending ETH Denver and for those who are just interested how to build with Fluence. Bernard and Polex will be leading the workshop. That's in VIP Hotel Conference Room, also one of the main locations for ETH Denver. And it starts 1 p.m. for 1.5 hours. That's not going to be recorded, but in person, if you're there, welcome. We just got some of the ETH Denver stats, and they have over 17,000 applications to attend, 6,000 bidlers applications, and 70% of applicants say that it's their first time at ETH Denver. So that kind of crowd is coming for Denver this year. And then Fluence Breakfast, 2nd or 3rd of March, we're confirming at the moment. That's also in one of the venues around the main venue, Biddle Hub. And then from 2nd of March through 5th of March, there is ETH Denver, the main event, and a lot of content there. We are having the stand, the booth, so we're going to have swag, and our team is there. So if you're there, very welcome to say hi, and if you have any questions, we're super happy to talk and to answer anything. As we are sponsoring ETH Denver, we are having Bounty. So you can check via the link. We will also share the links when I think we can already. Yeah? It's official now. So yeah, if you want to build, we have, cannot go through the link, but we have plenty of very good bounty prices this year. If you have started building, or if you have an idea building with Fluence, check out the bounty and go ahead. Okay. Thank you, Nadia, for sharing the link in the chat. And yeah, last but not least, we have a grant, a scholarship this year. If you want to build with Fluence, we are collaborating with the Developer DAO this year. So we are sponsoring a team to actually come to Denver, to travel to Denver for ETH Denver and build your project there. So for that, you have to fill in the application by February 8th. if you have an idea or if you're thinking of building something where Fluence can be helpful, go ahead, fill in the application and just wait to be selected.
Wow, that's very exciting. I think we also can have like another demo, because it seems like our Denver news was so encouraging. Iqbal, can you hear us?
Sorry. Right, can you hear me?
Yeah, we can hear you.
Yes. Hi guys. All right. So I straight away go for the demo, is it?
Well, you can talk about it a little bit, or you can straight go to the demo. It's up to you. It's a community call.
All right. I don't have so much of the demo for today, but one thing is that, like, just to share with everyone, that we actually managed to get the funding from all Outlier Ventures, right? Then we actually using Fluence Network as our base for the product that we actually built. It's actually based on the hackathon project that we actually won the first time with Fluence Network. So we actually further develop it, and now we actually managed to get funding, and we actually plan to do more for it, right? So I will share a little bit about this, the things that we're actually working on, right? Right. So okay. It's a bit more business compared to more technical, but I will share about the technical one part afterwards. Right. So basically what we actually try to build is that a dynamic NFT. Right. So it means that we actually try to look at how to build up to manage the NFT, right? Like the metadata for the NFT to be more dynamic for a lot of other use cases. So right now it's like most of the dynamic NFT are actually interacting with off-chain, or we have a ceramic network actually built for that, right? But actually to cater for a more production kind of development, that's where the bottleneck is, especially because I came from a Web3 gaming background. Right, so we actually have a lot of bottleneck, especially when we try to deal with NFT, right? Identify NFT, sharing, interoperability. The NFT is always been a problem, right? It means that you can build your application based on one NFT, based on a single application or a single dApp. But when you try to share the dApp, that's where all the problems started. So what we actually propose is actually to build up this new network, basically based on the Fluence network infrastructure, right? So it means that one thing that we are trying to look is not only to add the dynamic part, it's actually to add the computation for every NFTs, right? So every NFT can run a computation system and can be shared throughout the network. So this actually should give more value to NFT, especially is that I think we actually heard that we have a loyalty program. We had about like a Web3, not only for gaming, a loyalty program, a lot of Web2 applications try to jump into this Web3 or NFT hype. Right, so they need an infrastructure or tool to help of it. So one thing is that why we have it's not that ceramic network is not going to work. Ceramic network is definitely going to work, but the problem is that the tech gap for you to build up the whole ceramic application is actually quite huge. You need to have a lot of understanding of things. So this is where we see that the Fluence network can actually minimize or basically bridging the gap, right? Using it so that like we can have more onboarding from the Web2 to Web3 applications, right? So then we actually run throughout indexer and blockchains. So it means one of the key things that so this is going to be an independent NFT network by itself. Sorry, NFT metadata, not network, right? So they actually can run computation. You can set the state schema, right? Everything you need to run on this part. And lastly, is actually validate back to the blockchain itself as what we call verifier. We don't run any of the blockchain. And another beautiful thing that we look at this is that we can actually run a gasless transaction. Especially this is a big, huge thing, especially for an onboarding process for Web3 to be in Web3, right? And it's definitely a chain agnostic. I mean, we have went through this. We actually, Alexei actually the other day tried to request more support on this part. So actually on our side, we don't actually manage the storage inside the Fluence node. The Fluence node is basically like a mediator of the processing, right? So it means that like from the Fluence one, we actually interact directly with the Filecoin and any other blockchain using a JSON RPC, right? Then from there, you can actually, or more of the permanent storage will be done at the Filecoin and the blockchain, right? Whereby the Fluence services or the Fluence node will act as what we call like a catching system. I mean, like a validator in that sense, but not really a validator. So in a way that every time you actually insert the data, output the data will go through the services. One thing is that we need to do a modification. I think this one, based on what we have discussion with Alexei, is actually that we need to build an gateway, and like what we call, I mean, in microservices, if you're aware of it, we need what we call API gateways, right, for information on it. So example that if you want to access the information, they need to have what we call like a gateway. But as I understand that from Alexei, that's going to be very down the road, like a year, maybe about a year or something for it to be complete. So a way that we try to solve it is just that we have a node with the Nginx installed inside there, right? And just a modification for the nodes, right? Then the nodes, we have services that actually interact with the Fluence services. Not the best way of doing it, but it should work for now, right? So inside it, these are the services. So one thing that we try to make it differently is that we try to create a lot of services inside, right? Because that we wanted the application to be more modular in that sense, right? I mean, this one, initially we tried to build all this inside a single service, right? But then slowly we try to shift it out to have more independent of the services. And all this code is actually open source, so anyone can actually check it out on that part. Right. This is some of the core protocol that we're actually looking at. Right, so it means that there are a few key things that we try to look at is basically to make the nodes to be what we call a production ready. I mean, for the past 1 week or 2 weeks, I've been disturbing most of the question inside the group because try to figure out a lot of things inside, and I will tend to do it more for the next few more months, right? But we need to get. It means that one of the things is this, that we want to do a synchronization of information throughout all this table throughout the nodes, right? So in terms of production, want to actually use it at a speed that every node we have their own. So it means that to use it is same thing like how you do it in Fura. So it means that if you want to use the applications or to use it at the thing, you can have your own private nodes. So this actually should increase the speed in terms of when you do an application and interfacing it back with the API gateway. So it should help a lot of Web2 applications or any of the gamified projects to work. So they don't need to go in directly to the Fluence to actually manage and do on this part. So this is actually the data that actually stored the DHT table, right? This is some of the information that for the roadmap that we're actually discussing. So it means that this is just a basic overview of it. So it means that every node we have what we call, right now we are using as SQLite, right, of our source of data storage. So every node can actually using a services to sync the data, right? So it means that everyone we have the same data, any tampering of data should be able to detect it. We are actually at the very, very beginning of our development. So right now, like, I mean, feel free if anyone that are actually interested to take up the code. This is actually open source as well. Let me share it in the groups. So how we actually try to implement is, right. So this is all the services that are actually running, and we actually plan to do more. And this is actually the Fluence customs. I mean, we fork from Fluence and add up changing on the Docker Compose. Right, to add few things. Example that what the different that we try to add, example like Redis as our configurations, and like Nginx is another one. I think it's this one. Check back on this. Okay, so how things are work inside here is that right now this is actually very, very raw prototypes that we have. right? Sorry, I can't show you the demo since my laptop is out of batteries, so I can't use it in my Windows here, right? So example that you can actually run all this. Let me show you something here. So it means that this is actually quite important. It's not because right now is that if you want to listen for event changes, especially inside a blockchain, all this, normally we actually using an indexer example like the graph, or you using like we have few others. I can't remember that we can pull in the data, right? But what actually we're looking at is actually this is what we actually rebuild back. Actually, it's based on one of the base that we have previously. So it means that this is actually to communicate directly using a JSON RPC to communicate with the EVM, right? So this is actually to listen for events or things that we want to listen. So it just right now we can't actually make it like, I think this is one of the issue that we try to reach out like a bottleneck for now, is that Fluence cannot run like a long processing, because we tried it before, it's actually always timeout, right? So this is actually, we try to figure out how we can actually break it to more. So we have actually planned to have more nodes actually that run this JSON RPC. So it means that the node can actually synchronize, not say synchronize, like run it on the separate node. So it should actually release, because when we run it on a single block, it's actually, there's not a problem when we try to run it at a single block, but when we try to multiple block, that's where the bottleneck or problem that we actually have on. So it means that we're going to deploy more nodes that actually run the NPC there. So it means that we try to make it as what we call the indexer for Fluence, right? The idea is that we can actually use the graph, we can actually use all other, I mean, that's what we're actually using for the last hackathon, right? And we're actually using going forward. But what we feel that we need more control for the data that be inserted, right? When we want to read it, all this, because we don't want to store the data, right? And on top of that, that we need to run, the idea is that we want to run with this chain agnostic kind of thing. So it means that the graph only support a lot of it actually, but we want it to be more, I guess, me and the team is actually more open source kind of people. So we like it to be more open, right? Because we don't want to be attached or vendor locking to a certain applications in that sense. So, but what we see it in theory, we actually can run this on a multi-block block and synchronize it using the config. I mean, right now we actually tried we haven't tried the registry per se on this part, but we know that Alexei actually told me that you actually can store a certain data inside a registry, like a configuration file or things like that can be shared throughout the nodes. We haven't reached to that point yet. So at the moment, we actually have a node that called config. This one is the one that we actually store inside the node. At the moment, we plan to put it as a Redis data. Basically, this service is just handling a configuration file throughout the nodes. At this point, it's still not yet a built-in. The idea is actually to put it as a built-in on this part. Right? So this is one of a few examples that we actually run. I mean, you can take a look at the code. You can clone it. Sorry, I can't run the demo for this because my laptop out of juice for this time. So yeah, so far we have only reached it to create the NFT. Actually, they have more services that how the NFT is created on the below, right? And oh, by the way, that just to let you know that like, so every field inside the metadata, they actually have what we call a special ED 25519. So it means that if you are the owner, only if you are the owner that you can actually change the data set, things like that. It's still a bit crude, but yeah, things that you can see here as a demo on this part. Right, so yes, yeah, another thing that we try to look also like because of this EVM is actually to host the ABI that we need inside the Fluence node as well, something like a cache or a shareable ABI, right? Because right now we actually, before this, I think we have a problem that we actually try to use an Etherscan, whereby they actually have what we call rate limiter, and it's actually a bit tedious in terms of configuring. You need to pay all this kind of thing. I mean, vendor locking kind of thing, right? So we actually try to host it inside it. So the plan is that for the first one is to have this thing running. We do a lot of example because we saw that you have like actually an example using EVM gateway. If I'm not mistaken, one of the examples is actually having a blockchain gateway, right? So we actually do a lot of reference on that part. All right, so yeah, that's basically what we have done so far. I mean, maybe hopefully for the next month or so, we can actually show you more proper demos for this one. Sorry about that.
Iqbal, thank you very much for amazing product you're building. I mean, dynamic NFTs is something that should be really interesting in upcoming years. I mean, like it's something that haven't even been scratched remotely. So I'm pretty sure that, and I'm very excited that you are bringing Fluence as the sort of cornerstone for this project, and using it to develop your protocol and develop your solution on it. So thank you very much. Any questions or any comments for Iqbal? Because I'm really looking forward to seeing all that in action, because, well, it's something that's, I mean, right now I'm thinking about like billion of use cases it can be used, and it's very exciting.
Yeah, I mean, there definitely is that. I think one of the reasons will be accepted also because this is actually the outlier under the Falcon kind of investment, like a boot camp, right? So they actually was quite interested in this part, and then actually using it to promote Fluence to all these groups, a lot of people, because how we actually see it, rather than we need to build everything from zero, whereby it can take a longer time of it, whereby that I see that the advantage of Fluence at this part, right? So yeah, I mean, we definitely need a lot of more supports, more helps from the community and from the thing. So yes, on that part, I will request more help from you guys from time to time.
Yeah, just don't hesitate to ping us in Telegram or in Discord. So we are here to help you. And
thank you very much.
To see it in action. Okay, guys, I think that we are already like 1 hour into the call. So right now, I think it's time to wrap things up. So again, I want to re-emphasize on the ETH Denver stuff. So we have huge plans, hackathons, bounties. So please check out all those links. Please take a look at the application forms for the scholarship. Please take a look at our open positions, because we are hiring. We need more people to join us, and if you are interested in it, just like send us a message anywhere, or like email me directly. I can like put my email into the chat, and we can discuss it. Yeah, so here is my email, and I think it's time to check out. So guys, what are your thoughts? How was this community call? Maybe have any questions left? Anyone? Okay, I think then it's time to wrap up. So thank you everyone for joining. Thank you, Juha. Thank you, Iqbal, for those demos. I mean, that's really amazing. And see you guys next time. Yep. Have a good day. Bye-bye.
Thank you, everyone. Thank you, Fedor. Bye.
Bye-bye.
Thank
Thank you. Bye.